After we discuss about the association rules, how to calculate the support, how to use the a priori, it is time for us to look into the full picture of the association rules. As we discussed earlier, the association rules actually has two equations, including the one that we already discussed in the previous video, which is the support. Basically, it's the probability that transactions contains x and y together. Now, we want to focus on the confidence in this video. So, the confidence is the conditional probability that a transaction having x also contains y. Let's look into the two equations a little bit more. The first one, which is the one that we discussed, we're using the support indicating when x and y occurs together. The x is what we called the precedent. The y is what we call the consequent. So in support, the role of precedent as well as the consequent are not affecting the calculation of the support. Because you can see when all we trying to do previously is try to see how many times that it occurs during the total number of transactions. So x and y is basically being calculated in terms of how many times they occur together. So the role, again, in the precedent and as well as the consequent does not matter in the support. However, in confidence, that do matters. So take a look of the equations in this confidence. The confidence of x to y indicating that the precedent to the consequent will be calculated by the total amount of times that x and y occurs together divided by the precedence number of times in the transaction. So this is the conditional probability indicating that when x occurs, and again, x is our precedent, we want to see how many times that x and y occurs together, again, under the condition of x appears. So this makes the support and confidence very different from each other. And that is what we want to make sure that you understand the whole differences between the support and confidence so that we are able to find the association rules that pass not only the support but also the confidence. One more thing I want to emphasize again is that although the equation indicating that x and y, it doesn't mean that x has to be one item set, y has to be another one item set. X can be 3 item set, y can be 2 item set, so that they are not limited by number of item sets in the row of the precedent as well as the consequent. So based on the calculation of the confidence, we also need to set up what we call minimum confidence, just like when we were doing in the support. This minimum confidence is a user-defined value, and in this example of the video, we want to set up a minimum confidence of 60%. Of course, it can go higher, it can go lower, depending on the user-defined value. So, for a strong association rule, which means that the real association rules that we are interested in means that the frequent rules, then we already understand how do we define the frequent rules. That means the frequent rules indicating the rules that pass the minimum support. Not only that, but also pass the minimum confidence. So they have to pass the two checks. One is minimum support, the other one is the minimum confidence. So in this case, we are going to use the same example, and I listed out the confidence equations over here to make sure you understand what is going on. In our previous videos, when we were looking into the frequent item sets, we know that I1 and I2 will occur together. So if we look into the whole transactions, the total number of transactions are 9, and I1 and I2 occurs 1, 2, 3, and 4. So they pass 4 out of 9, which pass the minimum support, and therefore we know those are the frequent item sets. So they are frequent rules. However, we have not checked their confidence confidence yet. So it is time, after we get the frequent rules, it is time for us to check their confidence. As I mentioned, the role of the president is important when we are calculating the confidence. Therefore, this two-item set rule will be divided into two checks. First one is that using I1 as the precedent. The other one is using I2 as the precedent. Therefore, when we are using I1 as the precedent, that's indicating that when I1 occurs, then I2 will also occur. In order to make sure that is the rule we are interested in, we need to check their confidence. So you know the total number of times of x, which is the precedent of the times inside of this transaction example, we understand that it occurs 6 times of I1. So 1, 2, 3, 4, 5, and 6. And therefore, it will need to be divided by 6 as its denominator. For its numerator, is indicating that how many times of I1 and I2 occurs together. We already done that calculations. I1, I2, 1, 2, 3, and 4. 4 times of that occurs together. Therefore, the confidence of this rule is actually 66%. That passed our minimum confidence check, and therefore, this is a strong association rule. In other words, customers who buy I1 will also buy I2. That is the strong association rules that we would discover here. On the other side, if we use I2 as the precedent, I2 to I1 is actually not passing the minimum confidence. Why is that? Because I2 occurs more than I1. I2 occurs totally 7 times of it. And as you know, I1 and I2 occurs together for 4 times, and therefore this is actually like 56%, and it does not pass the minimum confidence that we set up. And therefore, we will not say this is the rule for the strong association rules. So once you understand this, I want to reflect on all the examples that we have discovered, or the 2-item sets that we have discovered in our previous support example. So for the previous support calculation, we actually find 6 2-item sets. So in this slide, we talk about first 3. The next slide, we talk the other 3. For the first one, I1 and I2, this is the one that we have just seen, and therefore we have C that has 1 rule that has been retrieved as the strong association rule. Now let's take a look of I1 and I3. So for I1 and I3, we use 1 as the precedent and use 3 as the precedent of the other check. Interestingly, you will see that item 1 occurs 6 times, item 3 also occurs 6 times. The total number of times they appear together are 4, and therefore both of them are strong association rules. Now let's take a look of the third 2-item set. I1 occurs 6 times, but I1 and I5 occurs together has only 2 times, and therefore this is not considered as the strong association rules. However, on the other side, this gives you actually a super strong association rules over here, because I5 occurs only 2 times here. Based on this condition, every time that I5 occurs, I1 also occurs. That's why it gives you a very strong association rules. This gives you the idea that how to set up a minimum confidence. If you want the rule to be a very strong rules, then you can set up into a very high, and you will only get those strong association rules with very high confidence. Of course, the number of rules that you will be able to retrieve is going to be much lower when you set up a high threshold. So on the other side, the other 3 2-item sets are 2, 3, 2, 4, and 2, 5, and we will need to repeat the whole process like what we have did over there, using in the 2-item set of 2 and 3, using 2 as a precedent, use 3 as another precedent. We will be able to find that 3 to 2 is actually a strong association rule. For 2 and 4, you will see similar things. 4 only occurs 2 times, so when 4 goes to 2, it becomes a strong association rule. However, when 2 goes to 4, since 2 occurs so many times, it's not really passing a minimum confidence. For 2 and 5, is similar things over here. Then we would be able to retrieve several strong association rules with 2 item sets now. However, that's not the only frequent rules that we have searched. We also, not only those 6 2-item sets, we also retrieve 2 3-item set rules. So this time, these things become more complicated because in order to calculate the confidence, 3-item set will need to be divided into several checks. Starting with item 1 goes to 2, 5. Item 2 goes to 1, 5. Item 5 goes to 1, 2. So that makes our precedent of 1-item set consequent as 2-item set. However, it can be the reverse condition, which means that we can have our precedent with 2-item sets and our consequent become 1-item set. In that case, we will have 1, 2 goes to 5. 1, 5 goes to 2, and 2, 5 goes to 1. So for every single 3-item set, you actually have 6 rules that you need to check. Starting with the precedent with 1 item, 1 goes to 2 and 5. So 1 totally occurs 6 times, and then how many times of 1, 2, and 5 all occurs together? We will see that 1 and 2. That's why it's 2 out of 6 times that item 1 has occurred. Obviously, this is not going to pass our minimum confidence. Similar things from 2 to 1 and 5. 2 occurs 7 times. That's the number of times of the precedent. And then 2 times that occurs all of them together. So this is obviously not passing our minimum confidence either. The last one is the one that passes because 5 again occurs only 2 times. And every time when item 5 occurs, they purchase 1, 2, and 5 all together. And that's why it's actually a very strong rules that we will be able to find. After we look into these 3 1-item to 2-item set rules, it is time for us to look into the other 3 2-item to 1-item rules. So starting from 1 and 2 goes to 5, we understand that 1 and 2 occurs 4 times and all of them occurs together only 2 times. So this is not passing. When 1, 5 goes to 2 as well as 2, 5 goes to 1, all of them passing with a very strong confidence because the number of 1, 5, you see that 1, 5 is 1 time, 1, 5 is another time. So there's only 2 times. Among those 2 times, all of them are being purchased together, 1, 2, and 5. That is how we will be able to deal with the 3-item sets. The other example that we have seen is the rules of 1, 2, and 3 as the 3-item set. This time, let's take a look of what's going on. We will still have those 6 rules to check, and one by one, we will understanding that if we have 1 item to 2 items, because they all occurs multiple times, and they only occurs all together for twice, none of them will pass the minimum confidence check. While we go from 2-item set to 1-item set, you can see that they are actually also not passing those rules. And that is how we will be able to check every single frequent rules that we found in the previous video that pass the minimum support in this topic of how do we find their confidence and try to identify all strong association rules. One more thing I want to mention is that those number of times of the transactions, no matter is 1-item to 2-item set or how many times 1 and 2 occurs together and how many times 1, 2, 3 occurs together, all of those are actually being calculated already. So when you were doing the support calculation, make sure it remembers all of those values because we will be able to reuse those values when we are calculating the confidence. And that is an important thing when you are writing a program to make sure you don't want to do repeated works. So you must feel this style very familiar because this was like almost the same slide that I want you guys to do in the previous video's assignment. So in this video, I want you guys to go one more step. In the previous assignment, you go into this only 5 transactions, identify the frequent patterns that pass the minimum support. So you already have those values. Now I want you guys to go one more step further, which saying that our minimum support is 80%. Use this minimum support. I want you to find all strong association rules, indicating the rules that pass not only the support but also the confidence. And we'll give the support and confidence over here. And of course, I just noticed that I make a typo over here. So saying that minimum confidence equals to 80%. To help you do this work a little bit further is that this is actually like the key to the previous assignment. You will see that we have several 2 item sets over here. We have 1, 2, 3, 4, 5 item sets over here, and 1, 3 item rules over here. So make sure you have those things in mind using the minimum confidence equal to 60%, and then try to find all the rules that pass the minimum support and minimum confidence, which forms the strong association rules.